Here we are for a couple more examples in section 3.6 on the chain rule. And these, remember that there are multiple ways you can do these. I think I'll be doing most of them with the cover up type of method, just because that's my personal favorite. But remember, you can use the Newton or the Leibniz notation as well. The most common ones I see people using are typically the Newton or the cover up method. Leibniz is a little bit lagging behind, but remember it really is the same thing as the Newton method, just with different notation. So with all that in mind, let's look at example 3 here. We have y equals sine of 3x cubed. Now, if I'm going to use cover up on this, I'm going to cover up that inner portion of the function. Okay, which remember, normally I just do this using my hand or a finger. You could put a finger there over 3x cubed, but since you guys can't really see that on the recording here, I would cover it up like that. And then to take the derivative dy dx, it would be the derivative of the outside portion, keep the inside the same. So derivative of sine is cosine. Keep the inside the same, so it's still covered up there. And then multiply by the derivative of the inside portion. Okay, derivative of the outside, keep the inside the same. Multiply by the derivative of the inside. Okay, and then you would uncover that portion and you would see that underneath that cover up is really 3x cubed, and so that would be what goes in those purple rectangle spots. And so we would have cosine of 3x cubed times derivative with respect to x of 3x cubed. And so the cosine bit, we just keep that the same, and then we take the derivative of 3x cubed by using our power rule. That would be 9x squared. So for the final notation on that derivative, you'd bring the 9x squared out to the front usually, and write it as 9x squared cosine 3x cubed. And that would be your answer for dy dx. Okay, let's hit another one here. We have y equals the square root of sine x. First things first, before you do anything else, rewrite that square root as a 1/2 exponent. We won't get too far without doing that. And then if I use my cover up method, I'm going to cover up, place a finger over that interior sine x function. So I'm going to write this as y equals stuff to the 1/2 power. That would be our cover up portion inside there. And so then the derivative dy dx, we would take the derivative of the outer function, keeping the inside the same. That would be 1/2, and then our purple cover up rectangle there to the negative 1/2 power. Make sure I get that negative, there we go. So 1/2 cover up to the negative 1/2 times the derivative of that inside portion, the covered up bit. Okay. And so we would uncover that now. You would lift up your finger and see that the covered portion is actually sine x. And so then you'd put that in the respective purple rectangle spots. So the next little derivative we take, derivative of the inside, is going to be the derivative of sine x, which is cosine x. Okay, so we would have 1/2 sine x to the negative 1/2 times cosine x, and then you would put that in whatever notation was most appropriate. I'd probably do something like this: cosine x in the numerator, and then stick our 2 and square root of sine x in the denominator, like so. And there's our derivative. That's dy dx. Okay, keep it rolling right along here. And we'll see what happens when we change the function just a little bit. These functions are all very similar, and they're based on some of the warm-up functions that we used for composition of functions. So this one here, we have the sine of the square root of x. That's the sine of x to the 1/2 power. And now we'll notice that that 1/2 power is inside the sine function rather than outside. So that changes our rewriting a little bit. If we're going to cover this up, we would cover up the inside x to the 1/2 power. So we'd have sine of that covered up portion. And then we'd go to take our derivative, dy dx. Derivative of the outside is cosine. Keep the inside exactly the same. And then multiply by the derivative of that inside portion. Like so. Right now they're covered up. But then as soon as you write that down, you would uncover and see that the inside is x to the 1/2. Okay, so what you're really doing is cosine of x to the 1/2 power times derivative with respect to x of x to the 1/2 power. And so you would have cosine of x to the 1/2 and multiply that by 1/2 x to the negative 1/2. All right, then you've basically got it. You could just clean up the notation on that. That would be cosine of square root x and then times 1/2 square root x. Or you could put that in a single fraction like this, cosine of the square root of x over 2 square root of x, and that would be our derivative. Okay. Now one more here as we move through these kind of quick examples. We have y equals 3 sine cubed x. First thing on this one is you'll probably want to rewrite it without the fancy trig notation, how the exponent is right next to the sine function. You probably want to rewrite this as y equals 3, and then that is sine x to the 3rd power. As you get more familiar with these derivative processes and the trig derivatives and everything that's coming together here, the chain rule, you might be able to just leave it in that original notation. But for right now, it's a little easier to start out by rewriting it as sine x to the 3rd. Okay, because that makes it a little clearer what we're going to need to cover up. Use your finger. Cover up the interior function there, which is going to be that sine x that's getting cubed. Okay, so we'll have 3 covered up portion raised to the 3rd power. And so then we just need to focus on taking the derivative of that outermost function first. Dy dx is going to be 9 covered up portion squared times the derivative of the covered up portion. Okay, the purple rectangle. All right. And then you would lift your finger up and see that you were covering sine x. And so this is really 9 sine x getting squared times the derivative of sine x. Okay. Then you'd take that derivative, 9 sine x squared, derivative of sine is cosine x. And then just to clean up the notation again, we can put this sine x getting squared back into the usual fancy trig notation. And we could say this is 9 sine squared x times cosine x. And that would be our derivative there. Okay, so there's some quick examples for you. And in the next video, we'll look at how to extend this chain rule to more than just 2 functions, where there's more than just one thing going on the inside. So I'll see you in the next video.